Thank you. It's a pleasure to be here. So I'm giving a talk actually in two parts. The first is the storm over coding for genetics that's occurring this year. For better or worse, I probably know more about that than almost anybody on Earth. And then the second thing is why tech assessments can go awry, which is a little more seat of the pants, but I think also important. So you can listen to what I'm saying, which will capture the high points. The slides are a little bit more detailed as a leave behind. And then especially on coding, we've written 2 white papers at Foley Hoag that are each 10, 15 pages and go into a lot of detail, what I'm going to summarize verbally. So we're going to talk about AMA CPT change, what they did this year, or last year, how CMS is handling it, and then a little bit more granular on Palmetto's program, which Matt mentioned. CPT changes was talked about for genetics for several years, and they finally put in 10 new pages of over 100 codes in November, a couple months ago. They're in 2 groups. Tier 1 are about 100 specific CPT codes for human genes, not for tests like Oncotype DX. And then they've got another set called Tier 2, which is 9 levels of complexity. So I think all future genetic tests will be handled by plugging them into one of these 9 levels. There was no place for IVD-MIA type tests, no place for next generation sequencing, and no place for branded tests, which I'll tell you a little bit more why that happened. So these are what the new codes look like. They start with some very specific genes. Some, like BRCA, have 6 or 8 forms. Then they get to just molecular pathology procedure level 1 through 9, which is very generic. And the level 1 through 9, they'll list 6, 8, 10 relatively rare genes, and they'll tell you what level of codes they go for the Tier 2 codes. Now, why didn't they handle IVD-MIA type codes? One reason is that the pathologists tend to drive things that happen at the AMA. Not companies and not labs, but pathologists, because they're a type of medical doctor. And there was a lot of animosity to boutique labs or sole source labs. You can see that in things that they've written. The College of American Pathologists recommended that the FDA regulate LDTs, that they regulate high-risk LDTs, and high-risk LDTs were defined exactly as the genomic health Oncotype test. So there's a lot of track record there. They don't want to put brand names in the AMA CPT book, and they may have foreseen valuation problems that we'll get to in a second. So by June, they had said we're going to do nothing with these specialty tests. And there was a lot of kickback from payers. They held some special meetings over the summer, and they came up with a new system, which they're going to probably approve in 2 weeks. They're going to make a category called MAAA, multi-analyte assay with algorithm. They've shown the text to stakeholders. If you have enough data, you'll be a Category 1 code, which is a real regular CPT code. And if not, they're going to make an appendix so that insurers can put in dozens or hundreds of codes in an appendix. Those codes, they say, will end with the letter M for MAAA, and you can get those codes much easier. They'll just sort of hand them out, but they won't consider them a real code or a validated code. Now, these 100 new codes hit Medicare last summer and last fall. And November 1st, Medicare surprised some stakeholders by saying we're not going to use them, and we're not going to assign prices to them, which was a sort of a blow to the people at the AMA that had put so much work into evaluating these codes. One of the main problems was pathologists, you don't need to read the slide, I'll tell you the slide. Pathologists announced that they were going to treat these all as physician pathology services, the work of a physician, and it goes into a special pricing system you may have heard of in Wall Street Journal articles and elsewhere called the RUC, the Resource Utilization Committee, where everything's treated as the service of a doctor. Now, these lab tests in genetics and genomics had always been considered clinical chemistry or form of clinical chemistry. Even if you look at guidelines, a lab can be directed by a physician with appropriate training or a PhD with appropriate training. And CMS could not resolve whether they were physician fee schedule tests or not. The pricing is very different. As you know, the stack codes have been used to price most genetic tests. Physician codes are priced based on minutes of doctor time, minutes of technician time, chemicals, and then a little allowance for capital equipment. And there are actually some very heavy discounts in there before they actually give you a Medicare price. So you end up getting about half as much as what the price will look like in these tables. It's sort of like Marx's labor theory of value, 42 minutes of technician, 11 minutes of physician. They add it up and you get the price of the test. So the high-value genomics industry, not very happy about that, and it throws in other things like co-pays for physician services. So we're essentially certain at our firm, and you can look at those white papers, that the policy and regulations favor genetics being on the clinical lab fee schedule. And that goes back to lawsuits in the early 1980s and bodies of law and regulation that date back that far. Medicare made it very hard to call a lab test a physician pathologist service. It's written into the law, very hard to do. It has to require a physician and not be performable by any other kind of medical professional. However, pathologists will argue that they've priced these tests, they're claiming their physician services, CMS staff might want to see a copay put on these tests, so there'll be a lot of lobbying this year. And then the Palmetto program, Matt just mentioned, they announced a new program in November. Palmetto's the Medicare carrier for the California region. I'm going to jump ahead a little. Basically, they've got new coding principles they want to roll out in a couple months, that they won't pay for stack codes unless you have a precision modifier such as a McKesson-Z code that tells you exactly what the test is. Otherwise, there's no payment. They will have to do coverage reviews on all genetic tests, so you don't get default coverage. You have to go through a review process. And payment, they would like to follow some more standardized principles there. So it's a very elaborate, forward-thinking move by a Medicare carrier, the California Medicare carrier, and these regional Medicare carriers are not known for ever doing anything that's their own demo program, their own initiative, their own innovation. So this is really going out on a limb in more ways than one. The second part of my talk, why technology assessments can go awry, why we should call it critical thinking medicine rather than evidence-based medicine. And this is based on my experiences over 6 or 7 years now in and outside the Medicare program, seeing technology assessments or misunderstandings that just go off the deep end and make no sense if you understand the content material. So, a lot of modern evidence-based medicine originated from articles and books that came out of Canada, a guy named David Sackett. But I started running across other authors in Canada who were sort of contrasting voices, Meadigan, Dickinson, Giacometti, and Janicek. There are some features of this approach to evidence-based medicine and why it results in technology assessment on genomic tests often looking really, really bad. Not to say that some genetic tests don't have enough data, but even the best validated ones may look bad. So that's what this part of the talk is about. One of the first things I noticed was if you look at the AHRQ assessment of the BRCA gene and its evidence, they conclude that the evidence that the BRCA gene is associated with breast cancer is at best poor to fair. Not the usefulness of the BRCA gene, the evidence that it's associated with breast cancer, which is a scientific fact, right? It's like saying the wall is painted white. But they rate the evidence as being poor to fair. For example, there are no randomized controlled trials that show the BRCA gene is assessed with breast cancer. I guess you'd put the BRCA gene into a zygote or something. And then working with different clients, we noted other AHRQ technology assessments. I'm not going to dwell on this because it's a short talk. That really made what I thought as an MD, PhD were severe mistakes of logic. And I started reading more about how people make decisions, and it turns out when people make decisions outside their area of expertise, their reasoning skills, their logical skills just go to pot. We all think we have good logical skills, right? Socrates is a man, all men are mortal, Socrates is mortal. But it's because you know what the words mean. If you're taken out of your comfort zone, people do very, very poorly at logic. That's a guy named Evans wrote papers on that. And one example, if you did evidence-based medicine on the question, does Herceptin work in American Indian women? You start with that question, and you do a PubMed search, and you define your keywords and define the language you're going to look at, and you get all the abstracts, and you do a survey, and you put them in a table, and it'll all be done very mechanically, and you conclude there's no evidence at all that Herceptin works in Indian women. So if you don't know what you're talking about and you frame the wrong question, you're going to get a really crazy answer. The other thing that we all know from daily life, you can tear apart anything. There was a famous letter in a British Medical Journal in 1922 where a guy totally decimated some work published earlier in the year by the wrong people, the wrong paradigm, the wrong experiments, the wrong interpretation. The paper he tore apart was the discovery of insulin, right? So you can critique anything. Why do we give such a high priority to randomized controlled trials? Because you want to rule out when something's only a correlation. There's a correlation between wearing shorts and eating an ice cream, okay? But if I take somebody to Toronto in January, put shorts on them, they won't start eating ice cream. Because the correlation was just a correlation, it wasn't causal. Women that take estrogen around menopause had less risk of Alzheimer's disease, but if you give estrogen to women, it doesn't prevent Alzheimer's disease. You need a randomized controlled trial to show that it's causal. But what happens with diagnostic tests? What happens in our business? You want there to be a correlation. That's what makes a diagnostic test. So if you have very high troponin in the emergency room, it means you're having an MI, a very strong correlation. But giving troponin to people doesn't cause an MI, right? It doesn't have to. The whole point of the test is to have a correlation. It's not bad news. So one of the key reasons for having a randomized controlled trial is to prove that a correlation is causal, but we only use the correlation in diagnostic tests. Another point that I'm making a more length in a white paper I'm writing, this index of analytical validity, clinical utility, is so general that if you just give it to somebody, it doesn't tell them what to do. It doesn't tell them how to design a research program or how to interpret a laboratory test. You need the kind of insight and the global view that Larry Lesko and Elizabeth Mansfield were talking about earlier. And Naomi Aronson said, well, sometimes you don't need an RCT. Well, tell us more about that. When don't you need an RCT, and why don't you need an RCT? And at least many people working in the field, a medical director in Missouri Medicare or Florida Blue Cross or someone, doesn't have any analytic framework. These three things don't add up either. You could have one gene that measures at 2% accuracy and another that measures at 4% accuracy, but the latter might be dramatically better for clinical validity. Nor does the amount of clinical validity really matter in itself in a vacuum. Here's a test where a high score takes you from 0 to 30% disease risk. A high score takes you from 0 to 30% disease risk. So the clinical validity power looks exactly the same. But the left one would be PSA, which is hugely criticized. The right one could be Oncotype DX, which is considered quite valuable. So the clinical validity, again, by itself doesn't really work. You need the clinical utility that Larry Lesko is talking about. So I've got three ways of potentially thinking about this clinical utility. One is to take, imagine you have 200-person cohorts, and you're able to use the test in one arm and not use the test in another, and how are they different? Which you could have a randomized controlled trial, but can you model it? Can you make a compelling argument for how much utility you have based on that? Another thing that's very helpful, and it goes to Naomi Aronson's examples, is the question you want to ask clinically and the question the test answers very close. Do they almost overlap? So if you take a tumor of unknown origin genomic test, which there were talks on yesterday, the question you want to ask is, this patient has an unknown tumor, what kind of cancer is it?